Emily's playing Alyssa in a tennis match. They are both standing at the baseline. Emily wants to win this last point so she can win the match. If Emily hits the ball from the baseline and it lands at Alyssa's feet at the opposite baseline, she will win the point. Find the initial velocity that Emily needs to hit the ball to win. Also, derive the equations that can determine velocity and acceleration at any given point.
Come in.
Hey Sarah, can you help me find the speed I need to hit the tennis ball so I can beat Alyssa at our tennis match?
I sure can.
After Emily hits the ball will move upward, decelerating until it reaches a maximum height and is momentarily at rest. The ball will then accelerate downward due to gravity until it hits the court. The velocity in the x direction is constant. The information we are given is that the initial height of the ball is at 1 meter. The total time of the flight is 1.45 seconds, and the position at the end of the flight is 0 meters. The length of the entire court is 23.78 meters.
In order to find the initial velocity, we took the kinematics equation y minus y initial equals v initial times t plus 1/2 at squared and plugged in the 0 for the position at the end of the flight of the tennis ball and the time 1.45 seconds, both which are given to us. When we plug those in, we get an initial velocity of 6.415 meters per second in the y direction. Now that we know the initial velocity, we can create our position formula using the same kinematics equation as in the last step. By taking the first and second derivatives of that equation, we can find the velocity and acceleration formulas. Please note that the acceleration is negative because in the first half of flight, acceleration impedes motion.
We then plugged our information into a chart with time, velocity, acceleration, speed, and direction. The 3 times we used were the beginning of the flight, the end of the flight, and the time when the ball was at its maximum height. When velocity and acceleration were different signs, the speed of the ball was decreasing, and it was moving upward. When the velocity and acceleration were the same sign, the ball was speeding up and going downward. At the maximum height, the ball was not moving. We then found the initial velocity in the x direction by plugging in the entire length of the court, 23.78 meters, and the time of the entire flight, 1.45 seconds. When you do the calculations, the initial velocity in the x direction is 16.4 meters per second. Using Pythagorean theorem with the initial velocities in the x and y directions, we were able to calculate that the initial velocity total was 17.6 meters per second. We plugged our 3 initial velocities into the law of cosines in order to find the angle at which Emily hit the tennis ball. This angle resulted in about 21.377 degrees.
This graph shows the displacement of the tennis ball over time. It starts at 1 because when Emily is hitting the tennis ball, she hits it 1 meter above the ground. This graph shows the velocity of the tennis ball over time. It starts at 6.415 and goes to 0 before going back up to 6.415, but in the negative direction, because the ball is now traveling downwards instead of upwards. This graph shows the acceleration of the tennis ball over time. It is at a steady negative 9.8 because that is the acceleration due to gravity. It is negative because as the ball goes up, which is the first part of flight, the force of gravity is impeding motion, so the acceleration is negative as it is getting closer to 0. In conclusion, Emily will have to hit the ball with an initial velocity of 17.6 meters per second at a 21.4 degree angle to the horizontal, or with a velocity of 6.415 meters per second in the y direction and a velocity of 16.4 meters per second in the x direction.
Hi Sarah, thanks for helping me win my tennis match.
No problem. Come in.
Hey Sarah, can you help me find the speed I need to hit the tennis ball so I can move? Hey Sarah, can you help me calculate the speed I I need to hit the tennis ball? So, can you help me find the velocity I need to...